The Arduino uses the calculate resistance function to determine the resistance of the PT1000 sensor. The first thing it does is take an analog voltage reading from pin 0. This voltage comes in off the potential divider that contains a 1000 ohm resistor and the PT1000 sensor. Since it's an analog pin, it can measure continuous voltages for values, rather than just on or off. The analog reading comes in as a 10-bit representation. It will need converting later. This line checks if there is a reading coming in from the sensor. If there isn't, it means that the sensor isn't connected, and that we need to display this error message to the LCD and to the serial monitor. The first thing we do is multiply the reading by the known input voltage coming in out of the Arduino itself. Then we divide that answer by 1024 to convert it from the 10-bit representation. Then this is just using the potential divider equation to obtain the resistance of the PT1000 sensor. That is then returned by the function. The Arduino then passes the resistance to the temperature convert function, which uses equations which have been calculated in MATLAB to convert it into temperature. These linear equations represent the PT1000 lookup tables that would usually be used in industry to find the temperature. Since these tables are large and take up memory on the Arduino, the decision was taken to convert the tables into linear equations. As the relationship between resistance and temperature is not quite linear, these equations have had to be separated into sections of 10 degrees Celsius. Depending on where the temperature is depends on the different linear equation used. Once that equation has been applied to the resistance, the function returns the current temperature. This is the loop function, which in Arduino means that this code loops continuously until the program either exits or the Arduino is reset. This section here checks if the user's temperature that it's set is 0. This only happens when the Arduino is on its first loop iteration, so it means that we need to ask the user to input a temperature. It runs the getTemperature function, which enables the use of the buttons to set the required temperature. Once that temperature has been set, the Arduino calls the calculate resistance function, which converts the pin 0 voltage into a value for the resistance of the temperature sensor. This value of resistance is then passed to the temperature convert function, which then converts the resistance into temperature. The Arduino then prints to the serial terminal and to the LCD screen both the required temperature set by the user and the current temperature of the water. This allows the user to see how long the water is going to take to heat up, approximately. Then we move on to the simple control. If the user temperature is greater than the temperature of the water, then we turn on the heater. If the user's temperature is less than the current temperature of the water, i.e. the water bath has reached and exceeded the temperature that is required, we turn off the heater.